Good morning, good afternoon, and good evening. Welcome back to Chapter 5. We're currently talking about transport. In the first video, we just talked about diffusion, how diffusion is the movement of particles from areas of high concentration to areas of low concentration. We're going to continue talking about passive transport. Passive transport doesn't require the cell to spend any energy for it to happen, and that's because the molecules, the particles, are moving down their concentration gradient. They're going the way they want to go. That's why they move that direction. Imagine I'm carrying a bowling ball, and I'm going to walk up a hill, and I'm going to stop in the middle of the hill, and I put the bowling ball on the ground. Which way is it going to want to go? If I let go of it, that bowling ball is just going to roll right straight down. That's the way it wants to go. It wants to go down the gradient. Our first method of passive transport is just simple diffusion. Simple diffusion is for things that can go straight through the cell membrane. And remember, anywhere you see PM in my notes, it stands for plasma membrane. I usually say cell membrane just because it's easier to say. Simple diffusion is for particles that can pass straight through the cell membrane. The only things that can do that are small and nonpolar particles, meaning they have to be small and nonpolar. Only small nonpolar particles can go straight through the cell membrane. Small nonpolar particles like oxygen, like carbon dioxide, like ethanol. Let's talk about ethanol for a quick second. Remember, I think we talked about this before. Ethanol is one of those molecules that, well, it's an organic molecule, and because it's an organic molecule, we can look at the suffix and it tells us what it is. What is OL? If it ends in OL, what kind of a molecule is it? And the answer is it is an alcohol. Now, when I say the word alcohol, you think one thing. You think stuff that you drink to get drunk. And remember, alcohol is not a thing. Alcohols are a class of things. There are lots of alcohols. You probably have more than one kind of alcohol in your house. Yeah, I got beer and wine, little James Beam. No, you've got drinking alcohol, which is ethanol. And you've got the rubbing alcohol, right? The stuff underneath your bathroom sink. So ethanol, when you see that, you go, oh yeah, isn't that the stuff they put in gas? Yes, it is exactly the stuff they put in gas. What is the alcohol they put in gas? It is literally the kind of alcohol that you can drink. Don't drink gas. You'll die. But yes, what they're putting in gasoline is literally the kind of alcohol that you can drink. Ethanol can go straight through the cell membrane. That's why if you drink on an empty stomach, you get drunk really fast, because it goes right through the membrane of your stomach, straight into your bloodstream. Only small, nonpolar molecules can go straight through the cell membrane. Those are the only ones that can do simple diffusion. Imagine sort of like the cell is a screen tent, and what can go straight through the screen tent? Water can go straight through, air can go straight through. That's what we're saying. So this screen tent is my plasma membrane, my cell membrane, and what can go straight through would be oxygen, carbon dioxide, as in like the stuff in air, and then alcohol, ethanol specifically, can go straight through. Our next variety of diffusion is called facilitated diffusion, and facilitated diffusion means diffusion that needs help. That's what the facilitated part is. The facilitated portion of this is that this is for molecules that can't go straight through the cell membrane. These are for molecules that need those channels, those channel proteins that allow them to come in. The rate of facilitated diffusion, exactly. If we go back to our screen tent idea, how do you get into the screen tent? You need a door, and so you have to unzip the door to get into the screen tent. The air can go straight through, but you need a door to go through. You need facilitation. You need an opening. So cells have these channel proteins. They've got these doors all over them. And so the rate of facilitated diffusion does still depend on the size of the particle. It does still depend on the temperature of the particle, but now we have a third condition. And this third condition is the number of doorways. Facilitated diffusion, the rate of facilitated diffusion is dependent upon the number of channel proteins. Fewer channel proteins means it can't happen as fast, and more channel proteins means it can happen a lot faster. So facilitated diffusion, it's diffusion that uses doorways. Here, again, is that picture that we saw in the first slide. Here's my cell membrane, and this is that channel protein, transport protein. It's got a tunnel going through it. These molecules, you can see, are large. These molecules are polar. If they're able to float around in water, they have to be polar. What's outside of the cell? Water. What's inside the cell? Water. To be able to move easily within water, you have to be polar. The problem with being polar is you can't go through this center nonpolar area of the cell membrane. So they need a facilitator, they need a doorway, they need a channel, they need help. And this is the thing that helps them to come in. Facilitated diffusion. Our last version of passive transport is called osmosis. You've probably heard of osmosis. Osmosis is a special variety of diffusion. The special variety of diffusion, and the definition for diffusion is in the definition for osmosis. It is the movement of particles from areas of high concentration to areas of low concentration. You note that I skipped a bunch of words when I did that. Those are the extra conditions. And now we're not talking about just the movement of any old thing. Now we're specifically talking about the movement of solvent particles. And the first question is, what's a solvent? Well, if you've ever made Kool-Aid, you know what a solvent is. A solvent is the thing something else dissolves into. So when you make Kool-Aid, what's the solvent? It's the water. The solute is what dissolves into the solvent. And in making Kool-Aid, what is your solute? It's the sugar and the Kool-Aid mix. The solute is dissolved into the solvent. So, diffusion talks about moving particles. Osmosis is a special variety of diffusion that specifically is not talking about the movement of just anything. Now we're specifically talking about the movement of the solvent molecules. And what is the solvent in the natural system? In life, in living systems, what is the stuff that everything is dissolved into? We just said it on the previous slide. What it's dissolved into is water. So we're talking about the movement of water molecules from areas of high water concentration to areas of low water concentration. That still is following our idea of diffusion. Moves from where there's a lot to where there's not much, down the gradient. But the last special condition is across a semipermeable membrane. And the semipermeable membrane that we're talking about is that plasma membrane. It is the cell membrane. We already said it's selectively permeable. Some things can go through, lots of things can't. So we're specifically now talking about the movement of water into and out of the cell. Water has to have its own little opening called an aquaporin. What does aqua mean? It means water. What is a pore? A pore is a hole. So an aquaporin, the name literally means what? Literally means water hole. This is a hole that water uses to get into and out of the cell. Aquaporin. Osmosis. It's the movement of water into and out of the cell across the membrane. And the cells, the water has to use aquaporins to do so. So if you look at this graphic, what we have here is a big tub. And in this tub, we've got a piece of filter paper dividing it into two halves. On the one side of the tub, we've got pure water, and that's what these little blue balls represent. They represent water molecules. On the right side of the tub, we've got sugar water. The green footballs are sugar molecules, and again, the little blue balls are water molecules. On which side of my filter paper is there more water? And the answer is, oh, it's equal. Look at the top. There's the same volume. No. The answer is the left side has more water. But it's the same volume on both sides. Right. But are the sugar molecules physically taking up space where water molecules could be? And the answer is yes. If it's the same volume, then therefore there has to be less water here, because the sugar is literally taking up places where water molecules could be. So where is my area of more water? On the left side. The water molecules can go through the filter paper. The sugar molecules can't. They're too big. So ideally, diffusion would say, well, the sugar molecules should move across from the right side to the left. The problem is this semipermeable membrane. It's that filter paper which prevents the sugar from moving across. So because the sugar can't move across, the water does. The water moves from area of high water concentration to area of low.